Saya jawabnya bingung juga. Bahasa Inggris bahasa Indonesia.
Tergantung audiens sih biasanya bahasa Indonesia sih.
Kalau ya lihat audiensnya aja kalau banyak
semua.
Ya nggak apa-apa. Playlist kalau untuk informasi dari Aminat nggak apa-apa bahasa Indonesia.
Ini nanti untuk masuk ke kamera audionya.
Oh,
Jadi
oke.
pakai ini. Oke.
Nanti
Tapi untuk
nggak
audio
bisa
di
pakai
sini.
ini aja.
Tapi ini tetap dipakai, ini juga tetap dipakai.
Okay.
Ini untuk kamera, kalau ini untuk di dalam ruangan.
Ini agak susah nih karena ada 2 orang berbicara.
Oh gitu,
Gantian,
nanti
gantian.
ganti-gantian berarti
Gantian
simpan di
aja.
sini aja nggak apa-apa.
Oke, baik.
Soalnya ini agak cukup luas juga.
Oke, jadi begitu aja ya.
Nah,
Oke.
di sini pun nggak apa-apa. Sikat aja.
Yang lain ya.
Ya biasa kalau di sini. Paling datangnya nelat.
1.15
Ya itu. Mudah-mudahan sih nggak nyampe 1.15.
Soalnya biar cepat ini juga. Mundur. Saya ke belakang dulu sebentar ya.
Masih rame di bawah nih. Tumpengan.
Baru sih acaranya sama acara guest Natalis. Seharusnya itu nggak mau cari hari lalu.
Nah ini saya udah fixkan date-nya, tanggalnya mungkin berapa minggu yang lalu. Terus info Pak Yogo soal JS-nya itu belakangan. Bentar lagi udah bisa main colok dia. Bentar lagi udah bisa main colok dia. Apa? Ya situ.
Tahu kan kenapa? Katanya pergi.
Nggak tahu layarnya. Bukan slide. Tapi ini full screen loh.
Saya tadi mau ada
Karena dia nggak full gini, nggak wide. Yang ini cuma kok apa kayak bukan saya yang minta. Wes, I'm honored. Kalau ini kecil ya, ambil aja. Dia udah berhak dia ngambil. Aduh gimana ini? Lumayan. Udah. Mau loading.
Iya. Adil.
time out. Iya. Mungkin dimulai aja kali ya. Bentar. Dah.
Presentasinya presentasinya
Oh, di Vigo.
langsung saja excellent.
Suruh sekolah lagi Mas Wisnu.
Langsung bintang 5 ya Pak.
Ini sebelum selesai udah boleh sih.
Biar nggak bias ya.
Allahu Akbar.
Super excellent. Nah, cukup
Astaga.
excellent. Tambahin super excellent.
Oke. Ya. Iya sebentar. Makanya tadi saya ngetes loadingnya dulu. 18 mungkin agak gedean kali. Masih kecil.
Kalau yang paling belakang kayaknya nggak.
Ini layarnya kepotong. Gimana ya? Iya. Wide soalnya.
Saya tektok dulu, saya tulis yang satu dulu yang besar ya.
Ya silahkan. Ini kalau mau dimulai silakan Mbak. Mau dimulai nggak apa-apa?
Boleh?
Hah?
Boleh.
Ini mic-nya di sini. Bentar. Tadi yang slide-nya. Ini kan ya?
Ini kalau streaming apa? YouTube ya?
Nggak tahu. Streamingnya kemana sih? YouTube ya?
YouTube.
Iya.
Oh.
Nggak kelihatan, nggak enakan maju, jadi biar kelihatan rame.
Oh, ya. Yang di belakang maju dong. Jangan di
Iya.
biar kelihatan ini ya. Biar kelihatan agak penuh gitu. Ya. Soalnya ada 2 baris ini kosong nih. Nah.
Iya.
Ayo maju. Kemana maju. Ya nggak apa-apa, nanti kalau kelas keluar aja, nggak apa-apa. Nggak enak sama saya gitu. Ya nanti kalau dimulai, bentar. Itu sudah ready ya? Ininya udah siap.
Udah siap tinggal live.
Oh oke, ya udah.
Oke, baik. Pakai ini juga atau nggak usah kali ya? Udah cukup kali.
Enggak, soalnya biar ke ruangan ada suara. Ini nggak nyala nggak? Tes. Udah. Coba.
Udah nyala sih dari tadi.
Coba.
Nggak. Bisa duduk tapi nggak ini nyala nih.
Nggak mau dia.
Nah, sip.
Nah udah, silakan. Ini sambil pegang aja. Susah ya. Ya udah.
Nggak
silakan.
salah. Gini aja nggak apa ya?
Ya.
Terima kasih banyak. Sebelumnya, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Selamat selamat datang kami ucapkan kepada rekan-rekan dosen dan mahasiswa sekalian ke salah satu acara kami yaitu Fulbright Research Presentation. Nama saya Mita, Associate Communications Officer dari Aminef. Pada siang hari ini kami akan mengadakan Fulbright Research Presentation yang nanti akan dipresentasikan oleh salah satu alumni Fulbright yang baru saja pulang ke Indonesia setelah menyelesaikan program S3 beliau di Wright State University, yaitu Dr. Adila Krisnadhi dari Fasilkom UI. Nah, sebelum kita masuk kepada bahasan dari Fulbright Research Presentation ini sendiri, yang sebagaimana teman-teman sudah bisa melihat bahwa kali ini judulnya adalah Data Integration Across Separate Institutions with Ontology Patterns and Linked Data Technology. Saya akan membuka dulu dengan sedikit informasi mengenai beasiswa Fulbright. Nah, kami tidak akan sampaikan semuanya, tapi hanya beberapa highlight saja. Untuk Anda semua warga negara Indonesia yang ingin studi di Amerika, itu bisa melalui beasiswa Fulbright pembiayaannya. Di Indonesia sendiri, Aminef adalah pengelola beasiswa Fulbright, di mana beasiswa Fulbright sudah berada di sini sejak 65 tahun yang lalu. Nah, kalau untuk mengapa belajar di Amerika Serikat, nah tentunya mungkin nanti bisa berbagi dengan Mas Adila langsung ya, bagaimana pengalaman beliau di sana. Tapi yang jelas sampai saat ini, terutama untuk ilmu yang berhubungan dengan ilmu komputer, bisa dibilang Amerika cukup di depan untuk perkembangannya. Jadi buat Anda, terutama yang jurusannya ilmu komputer, itu sangat bisa dipertimbangkan sekali untuk kuliah di Amerika. Nah, kalau untuk alumni Fulbright, karena memang beasiswanya sudah lama, jadi ya sudah cukup banyak. Apa saja peluangnya? Ada beberapa macam program, yaitu program Fulbright Master's Degree dan Ph.D. Kalau seperti Mas Adila, di sini programnya Ph.D. Sementara untuk Bapak Ibu dosen yang ada di Fasilkom UI, apabila Anda punya NIDN yang menunjukkan bahwa Anda adalah dosen tetap, bisa melamar Dikti Funded Fulbright Ph.D. untuk S3 di Amerika Serikat. Bidang studinya semuanya terbuka kecuali yang sifatnya klinis. Kalau untuk persyaratan umumnya kurang lebih sama saja ya, seperti beasiswa luar negeri lainnya, warga negara Indonesia dan sebagainya, kegiatan sosial. Tapi yang tidak kalah penting adalah mau pulang ke Indonesia untuk mendapatkan ilmu yang sudah didapatkannya. Kalau untuk persyaratan administrasinya bagaimana? Sama, kurang lebih juga sama saja dengan beasiswa lain, mengisi form aplikasi, surat rekomendasi, transkrip, ijazah, dan sebagainya. Ini kita masuk ke master's degree. Nah, yang jelas bagi mereka yang sudah lulus S1, entah itu dari dalam negeri, luar negeri, kampus negeri maupun swasta, boleh melamar asalkan bisa memenuhi persyaratan IPK dan juga TOEFL 550. Tapi kalau untuk ilmu komputer atau computer science ini bisa dikatakan di Amerika cukup kompetitif. Jadi kalau bisa saya sarankan, jangan melihat patokan paling rendah ya, karena 550, oh berarti saya 553 aman. Tidak seperti itu. Kalau bisa, karena ini adalah kompetisi, yang tertinggi tentunya akan mempunyai kesempatan yang lebih besar untuk dipertimbangkan. Oke. Bagaimana dengan S3? Kalau untuk S3 sama, persyaratannya juga harus lulus dari jenjang sebelumnya, yaitu S2. Tapi ada perbedaan pada TOEFL minimal, yaitu 575 dengan masa pembiayaan 3 tahun. Kalau untuk Dikti PhD, seperti tadi saya katakan, terbuka untuk dosen tetap yang punya NIDN. Persyaratan TOEFL-nya juga sama. Dan ada batas usia yaitu 50 tahun maksimal pada saat keberangkatan. Ini untuk menghindari supaya ketika sudah berangkat ke Amerika, kalau terlalu usianya terlalu senior ya, berangkat ke Amerika pulang ke sini memasuki masa pensiun, jadinya kan tidak punya kesempatan untuk mendharma baktikan ilmunya lagi begitu. Jadi ada batasan usianya. Oke. Untuk tenggat waktu pendaftaran ini adalah di tanggal 15 Februari tahun depan, berarti tahun 2018. Ini untuk yang keberangkatannya tahun 2019. Nah, kenapa kok panjang dan lama sekali? Banyak sekali alur yang dilewati. Oke. Program berikutnya adalah pertukaran untuk mahasiswa S1. Nah, ada yang masih S1 di sini ya? Kalau masih ada atau tidak ada di sini, silakan diinformasikan ke rekan-rekannya. Ada program pertukaran untuk mahasiswa S1 bagi mereka yang duduk di semester 1 sampai dengan maksimal semester 5, preferably, di mana nanti melalui program ini bisa mengikuti perkuliahan 1 semester di universitas di Amerika Serikat. Untuk program tersebut, pendaftarannya adalah tanggal 31 Desember. Nah, untuk informasi lebih lengkap mengenai program beasiswa apa saja yang kami tawarkan untuk warga negara Indonesia, itu bisa langsung masuk ke website Aminef di www.aminef.or.id. Kalau ada pertanyaan bisa disampaikan ke alamat email yang tertera info_fulbright_ind@aminef.or.id. Bisa juga datang ke kantor Aminef atau telepon tanpa harus ada appointment terlebih dahulu untuk bertemu dengan advisor atau staff kami. Sekiranya itu dulu untuk penjelasannya. Apabila ada pertanyaan mengenai beasiswa Fulbright ataupun beasiswa lainnya yang kami kelola untuk warga negara Indonesia, maka silakan nanti setelah Mas Adila selesai presentasi dan acara sudah di close, kami, saya, Mita dan juga rekan saya, Anita, masih berada di sini untuk menjawab pertanyaan rekan-rekan semua apabila ada. Baik, terima kasih banyak dan untuk selanjutnya mari kita dengarkan bersama Fulbright Research Presentation oleh Dr. Adila Alfa Krisnadhi. Mari kita berikan tepuk tangan yang meriah buat beliau.
Itu buat ke sini.
Ya, sudah.
Okay, thank you, Anita. Let's see. Saya tidak tahu itu yang menyimak dari streaming apakah ada yang tidak bisa berbahasa Indonesia. So maybe I'll start with English and then feel free to interrupt me if you have any question. You don't have to wait until the end of the presentation. It's a pretty long slides, but maybe it's not going to be everything that I'm going to discuss. Instead, in the middle, if you have any question or you know whatever, just raise your hand and I will be happy to answer your question. And because the topic may not be familiar with the audience, some of the things there are from more on the basics part of it. Some of you may already be familiar. I will mention Faris there. You will be familiar with a lot of the things I'm talking about. Anyway, so let's let's get started. So this is the topic that I did during my PhD stay there in the US, but it's not the only one actually. To be honest, I finished my PhD for 11 semesters, plus 3 semesters of postdoctoral research there. But the thing is that during these 11 semesters, I actually worked on 3 topics. The reason is because, well, the first one I got an idea and tried to work on it, publish something from it, but then somebody else, was able to come up with much better solution. So have to switch topics. And then the second topic is similar, and in the end, this is actually the third topic that I was working on. Well, that's the story of PhD students, I guess. Some of you here may be familiar. Anyway, right, so my stay there was generously funded by Fulbright. In addition, I received funding as part of the National Science Foundation project, which actually became this dissertation. Also, Rice University, who generously provided tuition waiver, and of course, Wasekomuni. Right, so I'm talking about data integration. I'm not sure how familiar you are with the idea of data integration, let alone ontology. But let me start with an example here, which is a scenario commonly found when we're talking about data integration. So the idea here is, here you have a scientist who is interested in finding some, this is an ocean scientist, he is interested in finding some bathymetry data. It is data about surface, not the surface, the surface of the bottom of the sea. Sea floor, right? Yes, sea floor surface. So this, the sea floor surface data is typically obtained through, some expedition through ships sailing over the ocean, and the ships has some sensors, in this case sonar sensor, and then the scientist also is interested in finding particular piece of data from particular area, geographical area. And then not just that piece of data, he is interested also in finding out the context about the data. For example, which expeditions contribute to those data, or who are the principal investigators or the researchers who are working on the data. So probably he wants to get contact and so on, right? Or maybe are there any publications related to the data or the relevant geographical area? So what happened here is that this is real in the sense that this is the scenario that is faced by many scientists in the US actually. So here the data, in order to find all those data, unfortunately the data is not available at one place. It's available in multiple locations maintained by multiple organizations. So that's the problem, right? So for example, on one part there is a repository maintaining geographic features data, and then another repository maintaining expedition data, another repository maintaining sensor instrument data, and so on, research grant, library, whatever, right? Naively, if you want to integrate this data, you would, without any help from the technology, you would start, well, what you would do is you inquire or ask around, right? You ask this one particular repository, give me all the geographic features. And then you ask the library, give me all the publications or things like that, right? And then try to integrate them together. Yeah. Now, this is something that happened not just in ocean science, but also in many areas. In business, obviously, if you look at, let's consider Universitas Indonesia. Universitas Indonesia has multiple systems serving the academic community in UI, right? So they have academic information system, it has a research information system, and so on, right? Employee information system and so on. So in order to oftentimes the scenario is to find information that involves getting pieces of data from different parts, even though it's not across a different organization. You look at science, for example, life science, you integrate data from genes, from proteins, and so on. You do integration all the time. So, given that problem, maybe the first question is, why don't we just use whatever tools we have, right? We have Google, for example. Google approaches originally is based on statistical approach, where this kind of information retrieval techniques based, similar to data mining. It is great tools. It would be able to analyze huge amount of data, but there is there are a few hidden assumptions there. One is that when you work on, this huge amount of data with data mining, the data is typically available in a single schema, so you don't work with multiple schemas. Yeah. What is schema? Schema is information about the data that allows you to, do query or modify the data and so on, right? Complete example, if you have tables, then the column names would be the schema. And then if you work with data mining, for example, the assumption is that data mining would work or would give you very good results if there is no, for example, duplicate records here. So what data miners do, before they start data mining, they do pre-processing first. They do cleaning, they do quality assurance and so on, so to make sure the data is ready to be mined before doing that. Yeah. And there should be no inconsistency or data conflicts there. This is obviously not, in the reality, that's not always the case, right? It's often that we have multiple independently managed data sources. Yes, you have different data models, different schema, or if you have the same entity, but the same entity occurs in different data repository, right? And obviously with different description. Yeah? So you wonder whether they're actually describing the same thing, right? Or maybe you know that you have a single entity occurring in different locations, different repositories, but the information in different repositories are conflicting. So if you integrate them together, you get inconsistency, you get problems. Not just that, different repositories would be set up differently. So you have different setup, different limitation in terms of query and so on. So that's the reality. So that's why data integration is still, a very difficult problem, and it's still ongoing. And it's not completely solved yet. Even though we do have increasingly smart search engines. So what is data integration anyway? Data integration is essentially process to provide a unified view over data at multiple or heterogeneous data sources. So if we abstract away the idea, you have this schematic diagram here. So essentially, if you have users on top, and then there is a layer between users, or there are a few layers between users and the data sources. The idea is that the user should not be burdened with creating queries differently for each data sources, right? So here we have mediator or sometimes data warehouse, depending on the way we set up the data integration. Formally speaking, data integration is simply a triple where you have a global schema, G, and you have a source or maybe a set of source or local schema, and then there is a mapping between the global and the local schema. So that's what it does essentially. Yeah. It's very simple, but behind it, we have a lot of challenges, right? For example, what kind of global schema can we accept here? Or if you have different local schemas expressed in different formal languages, how do you reconcile them together, right? That is not talking about yet about the architecture of the system itself. Yeah? So that's just on the language issue, right? Now, from the architecture side, we have essentially two main variants of data integration. One is what we call virtual integration or mediator based. So what it does is essentially you have data sources and then the data is not brought to the mediator. The mediator's task is simply to translate whatever query from the user into different queries to the data sources. That's the mediator's job. It doesn't store any data there. So that's why it's called virtual. Yeah. Now, at the mediator side, there is a global schema. Global schema, in the very simple way, is simply a set of relations. Or if you know database, you know schema would be a set of table specifications, like table name. If you have database about very typical database example would be a table about employee, table about dependent of this employee, maybe table about whatever employee, and then maybe organization hierarchy and so on, right? So you have different tables, and name of the table is the name of relation. So if you have multiple tables, you have multiple names of relations or a set of relations. Now, at the mediator level, in the global schema level, there is a set of relations, and the idea is that users would be able to express the query using the relation name available at the global level. The user is not aware about the tables or the schema at the local level or the data sources level. Now, in order to make the query work, obviously there has to be a way to translate the queries from the global using the symbols from the global schema into queries expressed using relations in the local schema. This is a very generic framework. Now, another variant would be materialized data integration, or more commonly known as data warehousing. It's just a different variant of data integration. Data warehousing is different because the same thing with virtual integration, it has a global schema, but now, when the global schema could be used to express query from the user, but now the middle layer here would store the data. Yeah? So the data sources periodically would be, they call it ETL, extract, transform, load. To extract from the source, transform it according to the global schema, and then load it to the data warehouse. That's data warehousing approach. Yeah. And of course, variants in between. And people come up with different approaches combining these two. Yeah. Now, what are the differences in terms of various issues? For example, in virtual integration, data is always current. Yeah. Whereas materialized integration, you may not necessarily get the most up-to-date data. Yeah. Because you do periodic updates. In terms of storage requirement, the virtual integration would be lower than the materialized integration because the data is not brought to the mediator, right? On the other hand, virtual integration would depend on the connection between the global schema layer to the data sources, right? If you do a query, every query will be sent to the local data sources. Therefore, depending if the data sources reside in multiple geographical locations, then you talk about network and so on, right? And then the query expressivity is restricted for virtual integration because it's restricted in the global schema, whereas the materialized integration is exactly like the normal database, and so on. So we have a few things. One thing I want to mention is that there is an issue of co-reference resolution or identity resolution. The issue is that if you have multiple data sources, there may be multiple descriptions about the same entity. So you want to consolidate these descriptions into one integrated view. with virtual integrations, because everything is done virtually, you can, practically you cannot do essentially the identity resolution on the fly, because it's very expensive operation. So whereas for materials integration, you could do it offline. Yeah, you could do it before or doing the extract, transform, load process. Now, that's about data integration architecture. Now, what are the challenges of data integration? Essentially, there is only one challenge, but we have a lot of variants of this challenge. The technical challenge, is heterogeneity. Well, you see the peppers there, peppers and chili and so on. You have like multiple variants, multiple variations of the same thing, for example. So heterogeneity. And the main cause of heterogeneity is data source independent, because data sources are presumably maintained and managed by different organizations. So there is independence between the data sources. You cannot assume that they would use the same schema. Yeah? Even the developers, even the same data sources, sometimes you get, if you do, for example, you update databases, you get different schema because of different developers, right? Now, in this case, I have 5 types of heterogeneity in data integration that leads to the problem. And data integration aims to bridge all these types of heterogeneity. Yeah. The first one is infrastructure. So this concerns the means of access, not the data itself. Heterogeneity because of the means of access. Yeah. Protocols, formats, query framework, and so on. And then on the syntactical aspect, this concerns the encoding of data values. So data values may be, let's talk about character format. You have Unicode, you have ASCII, number format, and so on. So you have different, this is related to data exchange format and so on. Yeah, the syntactical level. Now, moving on, we have data model heterogeneity on the data model. You could have relational data model. This is probably the most common. But also, you have maybe data model based on XML, or object-oriented, or even graph data model, and so on. So you have different data models that need to be integrated. And then, there is also a structural heterogeneity. This concerns different ways of representing some reality. So for example, modeling alternative between relation, attribute, and value, for example, we want to represent a human that consists of man and woman. Yeah. And this human or this person would have IDs, would have first name, and would have surname. So one way would be, well, you consider man and woman as separate relations, and both relations would have these 3 information. Or you could simply use, for example, Boolean or integer attributes, right? In the second one, right? You have person, identifier, first name, surname, and then a flag saying whether it's a man or it's a male or it's a female. Then you know which one is a man or which one is a woman in this case, right? And then you may wonder if both male and female is true, for example. And then there is also a way representing this using value. For example, you have person, you have identifier, well, I forgot the surname, first name and surname, and the sex column indicates it contains maybe a string describing male or a string female, or they are all representing the same thing, right? And it's heterogeneity. Now you have, that's one example. Another example will be between normalized and denormalized relations. If you're familiar with database design process, you will be familiar with normalizing databases. And sometimes all these things are also influenced by the data model you choose to work with. And the last heterogeneity, which is considered the most difficult, is semantic heterogeneity. This concerns the meaning of the data and the schema components. There are a lot of variants or a lot of examples of semantic heterogeneity. For example, naming conflicts. You have a column called name and another column called surname. Are they the same thing or not? Maybe they are the same thing, but then you have different labels. Yeah? Or you have values saying GL dot space Margonda and then Jalan space Margonda. They are the same object? Maybe here in Depok they are the same object. Or you talk about, for example, information about salary, where the salary here is just given as numbers, as integers. Then the salary may be in actually US dollar or maybe in rupiah, right? Or the term queen, is it Queen of England or is it Queen the band? There's our semantic heterogeneity. Because of naming conflicts. Another thing is because of duplicates, right? Same entity occurring in multiple sources or multiple records of the same source. The reason why this happens is because, for example, during data entry, you enter duplicate data and there is no check done there. Or simply because the data comes from observation in nature. For example, you get sensors and same entity is observed multiple times. Or there is no consistent global IDs. For example, for books, you have IDs from Hasilcom's library. You have IDs from main library of the university, right? And heterogeneity because of inconsistency. Yeah, this happens usually because you have duplicate records of an entity, and in these duplicate records on the same attribute, both records exhibit different values. Yeah. For example, I have a data about person where about me, for example, where the first name has the value would be Adila, and the other record, the first name value is just A, for example, because maybe the data maintainer doesn't know about that my name is Adila, so he just knows the initial, for example, so he entered initial only, right? So you have conflicts there. Now, that's just technical aspects, and the other challenge is the social aspects, the non-technical part. There is all of this could be boiled down typically into one cause, namely inability or unwillingness to participate in the data integration effort. Because when you're talking about multiple organizations, different organizations, they have different degree of readiness. They have, maybe the policy or maybe the boss there doesn't want the data to be shared. Yeah, and often the case, data is considered assets, as if it's financial assets. So you don't want to share. Although, from the other perspective, you know that if you integrate data, you make it added value. Yeah. Well, it's kind of hard to explain. Yeah? It's the job of the engineer, of course, to explain. But integration is sometimes avoided because they're afraid of losing the assets. Yeah? Because if you share, essentially, you're giving up assets. That's the view. Yeah. So as Alan Halevi said, by the way, he's now at Google. He said data integration is AI complete, meaning that it is as hard as artificial intelligence itself, and therefore completely automated solutions are unlikely. Okay, this is debatable, but that's how they say, right? So typically, what the aim of any data integration effort is to reduce human effort. Of course, when you talk about human effort, there are different ways human effort may appear, right? Maybe in terms of schema maintenance, maybe in terms of transforming the data to make it available for integration, and so there are a lot of things. Yeah. Because it's a big area, a lot of challenges there. There are still many open issues there. Well, of course we have to choose, right? I mean, otherwise I wouldn't get one topic to do dissertation. So you have to choose. So what we've chosen is focusing on the problem of bridging semantic and structural heterogeneity. This is a very generic description. Yeah, there are of course specific contributions there, but the general thing is that we want to bridge semantic conceptual heterogeneity, assuming that the other types of heterogeneity have been solved, maybe using existing standards. In my case, the idea is that for the infrastructure, the syntactic standard, and the data model are whatever offered by linked data technology. So linked data, I will explain about this in detail. Essentially, it gives you a particular data model, and together with this data model, there are different solutions, there are different infrastructure solutions. And then we could focus on the semantic and conceptual heterogeneity through the use of ontology. So I'm not sure how familiar you are with ontology and linked data, so I'll go with the basics here. By the way, feel free to interrupt me if you have any questions. So let's talk about ontology. Ontology, the term ontology is probably originally from philosophy, but ontology here in our context is in computer science, and it was this definition from Tom Gruber, which is one that is very often cited here in the study of ontology. So ontology is specification of conceptualization. So I wonder, what is specification and what is conceptualization? Now, conceptualization in this case is whatever abstraction in your head, so on the cognitive level, in your head about something. In your head about person. What I conceptualize about person may be different from what you conceptualize about person. Maybe because, well, I conceptualize person in terms of the names and the address. Maybe you want to conceptualize person, not just the name, maybe the address, maybe the date of birth, or maybe that the person has 2 hands and 2 legs, for example. So that's conceptualization. Now, yeah, we're talking about, we're aiming for this whatever conceptualization to be processable by machine. So we want to write this down explicitly. The results of writing this down explicitly is called specification. Yeah? So specification of conceptualizations. Of course, you want to write down, you need some language, right? And in this case, we're using formal or logical language. Now, that's for generic level. There is nothing here talking about data integration, right? But apparently, because specification of conceptualization results really in the form of a set of logical statements or a set of formulas, yeah. And because database schema is really just a set of relations which could be seen as a set of formulas, so you could use ontology as the global schema. Yeah, that's the idea. So ontology-based data integration is really just data integration where the global schema is an ontology. In database setting, global schema is simply just a set of relation, a set of table names, and possibly with additional constraints within tables. Yeah. With ontology, you could have much more expressive global schema. And in fact, this is what Gruber proposed. Yeah. The major aim of having ontology is to be able to bridge semantic heterogeneity. For example, we talk about multiple descriptions of the same entity from different data sources, right? So you want to bridge them together. The language of database schema is not strong enough to express this, to express that you have description about entity A, description about entity B, and they are different, but they have to be reconciled. It's not strong enough. So that's the intuition. Yeah. Now, if you look at also the other difference is that database schema is for structuring the data. So there is no consideration about what happened if I want to share the schema. Yeah. Because if you want to do data integration, you have to somehow share your schema in order, for the schema to be able to be reconciled, right? So you need to share the schema. You need to ensure that different schemas work together or interoperate together. So there is a knowledge sharing aspects there, and database relation in general is not strong enough. So ontology is considered stronger, so they use ontology. Another difference is that database schema talks about data, constraints about data in that particular database. Constraints about the data. Yeah, it doesn't say. It doesn't necessarily say about the meaning of the data. Yeah. For example, if I have a table about person and table about human, I want to say that everything that is a person is also human. Yeah. Not necessarily you could do that with database schema. You need a logical formula expressing the relation, or you need an axiom expressing this relation. Or you want to define that person is a disjoint union of man and woman, for example. Yeah. So ontology is viewed, better as better global schema because the vocabulary is equipped with explicit semantics there. You have, with logical formula. Now, Ushwal said that unless the following things are true, namely, there is a widespread. If there is less widespread agreement about the meaning of a term and the syntax for expressing it, also the less number of software built by humans who could correctly embed the agreed meaning of a term, and the less that all databases and web pages use the term in an agreed way, then the more it is important to have an explicit formal semantics of the term, declarative semantics in this case, so that machine could work on it. Now the problem with this view is that, in the ontology research, people tend to focus on the ontology itself. Studying ontologies for the sake of ontologies. So maybe building ontology about the world. So I want to describe everything there is in the world. Well, it's ambitious, and people attempted that, but nobody succeeded. But that's the focus of ontology. And actually, in the beginning of the semantic web research, which the field that I was working on, that I'm still working on, the first focus really on the ontologies. That's why ontology languages was first recommended in 2004. Yeah? So really on the ontologies. But the problem is that with the ontologies, sometimes you focus too much on ontologies, as you get something like this. So you have a structure like this, infrastructure framework like this. You have on the global level, you have global ontology, where this global ontologies tend to be foundational or upper level ontologies. Now, of course, if I say I want to describe everything there is in the world, it doesn't prevent you to want the same thing, right? So what happens is that, not just one person or the one group of people wanting to describe everything there is in the world. There are multiple groups, so we have multiple global ontologies, where each of the ontologies, because you want to describe everything about the world, you get a lot of terms, a lot of concepts, a lot of axioms. If I give you an ontology with 5 million axioms, imagine that is psych. It's one of the ontologies. How would you work with it? You would be, how do I start from it, right? It's very difficult. Yeah? There is one, for example, an ontology that is still being used now. It's called SWEET, SWEET. It's a foundational upper ontology maintained by NASA about environmental terms, like physical, chemical, physical phenomena. It's difficult to understand, but they're still maintaining it because some people still use it. It's difficult because there's a lot of axioms. Now, in short, here, because you have competing ontologies, and it doesn't mean that there is only one ontology that is right, because you cannot say that that there is one global truth. Yeah, maybe there are two versions of truth. It's just it may depend on the context and so on. So it's kind of it's hard to, or it's impossible to force everybody to accept one thing only. Yeah, and that's what happened earlier, though. Yeah. So let's talk about standards. So what they wanted is pick my ontology as the standard. So the problem with standard is that, okay, we have 14 standards. Okay, this is bad. There are 14 standards. We need to, make them work together. So let's make another standard with the aim to make all these 14 standards to move together. Now the end product is now you have 15 standards. And the first standard, the group of people who proposed the standard, no, I don't want to use the last one, I want to make another one. So that's what happened. Yeah? So you cannot standardize the meaning of everything in the world. But of course, standards helps somehow. Yeah? So there's an example. How do you standardize the definition of road? What is road anyway? Road? I'll give you two examples. One, when road is considered as a line connecting 2 points. That is probably the easiest way to understand, right? But there is also another view where road is actually a divider. A divider of what? One application would be in ecology. You have an ecology, so imagine you have a national park here, and you suddenly build a road across the park. Now you divide the park into two, where the animals from one side may not necessarily be able to move to the other side. So it's a divider. So it depends on what you're talking about, right? So you cannot standardize the meaning of the word. How about forest? What is forest anyway? Forest in Indonesian version would be different from American version. That's true. Yeah. In fact, I've heard that there are more than 50 definitions of forest around the world. Yeah. How about marriage? Okay, marriage in Indonesia is defined in Undang-Undang Perkawinan, right? Oh no, yeah. Is that the name of the undang-undang? Yeah, okay. In the US, different states would have different definitions of marriage. Or maybe some states allow same-sex marriage. That's true. So marriage is defined not just between man and woman, but maybe between man and man, or woman and woman. That's true. That's in the US. Yeah. So the lesson is that there is no single global truth, and you cannot standardize everything, because ambiguity is both a bug, a problem, but also a feature. You have to work on it, right? So that's the idea. So some standards, of course, are still helpful. So the idea is that instead of standardizing the meaning of everything, we standardize the language to specify those meanings. Yeah. That's where OWL comes into play. Yeah, I put picture there, right? OWL comes into play. Let me skip the details of OWL, right? Let me just go through the argument and then show you a little bit about my work. So now with OWL, I'll give you an example later, that it can be used to describe foundational ontologies, but then there is still a problem, because big ontologies, is hard to understand, and it enforces certain restrictions on the meaning that may not necessarily be agreed upon by others. So you cannot, that's the problem, right? It's too rigid. Now, if you want to do data integration, you don't assume that the data, for example, let's say data integration involving 3 organizations. You would not assume that there will be only 3 organizations participating in data integration. It may be in the future there are more. Now, what happens if you have big ontologies? Well, you may break something because new data sources coming in may break the assumption in the ontology used for the Google schema. And also, the foundational ontologies, they are too abstract, so it's far from the actual data. Yeah? And this is what happened in this semantic community, is that, okay, now we don't want the ontologies. That's what happened in circa 2009-ish, 2008-ish, where people started to think, no, ontology is useless. Because they're kind of talking about ontology for the sake of ontology. So there is no data yet. So what happened is that, okay, let's publish data and more data. What matters is the data. It's kind of backlash, so it's kind of reaction. So what they do is, okay, publish data according to these 4 principles. It's called linked data principles. So this is what about linked data now. So 1, use URIs, uniform resource identifiers, as names of things. In database, you have primary key, right? Now URIs could be seen as a primary key, or to be specific, global primary key. Because, well, if you set a URI for a resource, especially it's an HTTP URI, then essentially you say, well, this is the name of the thing, and in addition, with HTTP URIs, you could open your browser, put the HTTP URIs there, and do a lookup and get more information about the thing. Yeah, and that's the standard, right? Use URIs as names of things. Use HTTP URIs so that people can look up using their browser. You look up those names using common internet browser, and then when someone looks up the URI, then it's the responsibility of the URI publishers to provide useful information, maybe in certain formats. And more importantly, URIs also acts as links. Alright? Now you could collect a few URIs together, so that now you could make links between objects to another objects. Yeah? The links itself has a name, and it's also URIs. So let me give you an example. This is probably a good way. Here it is. So here is an example. So consider this example where there are a few statements. One, Bob is a person. Bob is a friend of Alice. So you have a relation, right, between Bob and Alice. And then Bob is born on the 4th of July, 1990. And then Bob is interested in the Mona Lisa. And then the Mona Lisa was created by Leonardo da Vinci, and the video of La Joconde Washington, I don't know how to read it, is about the Mona Lisa. So these are typical knowledge, right? Now how do you express this using the linked data idea? Here is how you would do it. So you view everything as graph. Yeah? Graph where entities act as node. So you have a node about Bob, and then there is a node for Alice here on the upper left, yeah, and there is a relation is friend of, and then there is a node for Mona Lisa, and so on, Leonardo da Vinci, and so on. So you have this. Now all of this, yeah, could be expressed in terms of linked data, namely Bob there is now a URI, Alice is now URI, Leonardo da Vinci is URI, and so on. But also, the relation itself is friend of, for example. It's a name of something, right? So you have a URI. And a graph could now be seen simply as a set of triples connecting node, edge, node. Yeah, node, edge, node. So you have a set of triples. Yeah, so you get. Where is the? Should be somewhere. Here. I forgot here it is. Yeah, here. Bear with me with the slightly convoluted text there. So here the first triple. Here, this is Bob. This is URI for Bob. Yeah. There is no standard in writing down a URI except the syntax of URI has to be something like this. But whether it uses Bob, hashtag me or just Bob or whatever, yeah, there is no standard there. And then stating that Bob is a person, then the is a relation in this case is represented by this URI. Yeah. Yeah. And then person is that one. Yeah. So now everything is a triple. In fact, it's not just triple as in the graph way, because you could have an edge from an edge to another edge. Why? Because an edge itself is a URI, right? It could be positioned as the subject of triple. Yeah? Okay. So don't think of there is no separation between edges and nodes, because edges could be seen as a nodes as well. So that's the key of RDF, the RDF data. And you could easily visualize this as graph. Now, so this is how it looks like. So what it offers is that it offers simple standard data model. It's very simple. It's just a set of triples, standard data model. And then not just that, the standard or the W3C standards is from the World Wide Web Consortium. W3C standards also specifies the serialization syntax, namely how you write it down to exchange RDF data. Yeah, so you have syntactic heterogeneity somehow, bridge there, right? Because you could encode the graph there as XML or another notation. Yeah, there is a standard data access protocol using HTTP. There is standard query language using Spark, and very simple principles for data publishing. You could publish RDF data simply as a text file. Yeah, there is no whatever binary encoding or whatever, right? It's really just text. Now, because of these simple principles, the number of data sets in RDF published increased exponentially. In the 10 years since it was first advocated, these principles, now there is a cloud called linked data cloud containing overall more than 100 billion triples with more than 1,000 data sets. It's actually, if you compare with the internet, it's still small, but it's pretty astonishing. So here is an example of what happened in 2007. So in 2007, RDF data sets consist only just this data, DBpedia, which is the data extracted from the info boxes of Wikipedia, and then US Census data is made available as RDF and so on. So this DBLP, DBLP? DBLP is a bibliography repository for computer science. So the list of publications in computer science is there in DBLP. Now, that's 2007. 2017, where is DBpedia? Actually here. Yeah. So, now you have a growth, right? Exponential growth. Now the question is, how do we work on this? Yeah? We have a lot of data, and it's structured data. Remember, it's a set of triples, it's structured. Yeah? It's not something like text, where you need to do language processing, right? Yeah? So linked data integration approach is really just use RDF data, publish them, and because the URIs also act as links, yeah, essentially you already have links between different data sources. Yeah, you could express, say for example, if you have data about me, then URI about me in one data source and another data source with probably with the same URI would mean that it would be the same thing. Yeah. But of course, the problem is that URI does not assume something like primary key. If you have different primary keys, then you mean different objects, right? But here, you have different URIs, you don't necessarily mean they are different. They may be the same. Yeah, it's actually interesting issues here. For research issues still open if you are interested in working on it. Yeah, given two URIs in simple terms, given two URIs in different data sets, do they mean the same object or not? Yeah. Now the problem is that because very simple, yeah, it's messy, yeah. Even though it's structured, it's still messy. And if you want to work with it, yeah, you need to use some standard vocabulary, yeah, or you need to assume that the data is published in standard vocabulary and under the same semantics. And it's impossible because of extreme heterogeneity, yeah. And also there is no mediator because while publish the data as RDF data, and if you want to query the data, you need to know where the data, you need to know the structure, the schematic structure of the data set. Remember, in RDF, there is no schema as in database. It's schemaless. Yeah? Or there is no explicit schema, so it's hard. So, the syntactic data model is heterogeneity become far less complicated. And here is an example of how to query it. You have multiple sources. Suppose here is data from LinkMDB and there is data from Wikipedia, and we want to find out the name of an actor and his birth date, yeah, so that the actor acts in a movie given by this, yeah, and the birth date data is from the Wikipedia. Now the problem is this, of course, if you want to do that, you need to know that actually the Wikipedia has the birth date data and also the LinkMDB has the movie data, right? So somehow the schema is needed, but the data set in RDF does not have schema. So here's another example. You have this cell triples, like 5 triples, talking about Jim Henson. Jim Henson is a famous actor who plays the characters Ernie and Kermit. Yeah? So if you have this very simple structure, now you wonder, what character does Jim Henson play in Sesame Street? Is it Ernie? Is it Kermit? The answer is actually both. So here is a problem with simple, pure RDF data. Right. So with RDF with linked data, first it's too extreme reaction to ontology. They just say ontology is useless. Actually, it's not the case. So and every extreme heterogeneity, because of anybody can say anything about anything, and there is no conceptual description about data sets, and then formulating query is very difficult. So we need to bring back ontology. So that's the idea here. Ontology patterns. So we have the good thing about ontology, it's precise, it's machine readable, and linked data provides simplicity, flexibility, yeah, in a publishing open and web friendly way. And on the other hand, ontology has a problem, yeah, at least existing ones at that time, is too difficult to understand, too abstract, too far away from the data, too rigid. Whereas linked data, well, it lacks schema, so too little shareable schema information, so very difficult to understand data set. So how do we combine these together? So can we build a data integration framework that combines the strength of both and less of their weaknesses, of course? So what I did was, okay, looking at what we call ontology design patterns. So this big question is divided into 2 questions. This is the first one: what kind of ontology is suitable for as a global schema? And the hypothesis was ontology design patterns would be suitable as a global schema, combining the goodness of both. Yeah, and it's done. The research was done in a project called GeoLink project, which is funded by NSF, and the result of this study is a collection of what we call content patterns. Yeah, what is content patterns? We will see later. For this particular case, ocean science. Yeah, and this content patterns is suitable for data integration. Yeah. So what is ontology design pattern? It's actually, if you are familiar with software design pattern, right? Software design patterns could be seen as a template. Yeah. In a way, ontology design pattern is a template as well. Yeah. Where, because this template recurs in different places. Yeah. So you have recurrent solution. Yeah. Recurrent solution. But for particular purpose where we say, for example, in ontology in OWL, you cannot express by a ternary relation directly because OWL is limited. It's just it could express binary relation, but no more. So how do we express ternary relation, for instance? So you have a pattern for that. Yeah, so you have a template. So you follow this template, then you get a nice set of axioms expressing the ternary relation. But more often, yeah, we need patterns for content. What is content in this case? It is something related to the cognitive aspects of modeling. So if you have a model, you want to model something in ocean science, then think about, if you want to integrate data in ocean science, then you wonder what kind of notions what kind of notions there is in ocean science. Maybe cruise, maybe vessel, right? You would expect that cruise, vessel, and so on would recur in different data sources about ocean science. Yeah, so that's where the pattern comes into play. So because they recur. Now, in terms of implementation, content ODP must be small and highly modular. So we don't want to model vessel as a really big ontology where now you involve definitions about other things there. We want to focus, localize the definitions only about vessel. Yeah. So there are a lot of design patterns there, and one of them is content pattern. And this is the idea. So each content pattern model just one notion. So an ontology pattern should be focused on one notion. Now, the consequence of that is that you have very modular collection, yeah, which presumably is easier to extend, but it's more flexible, and you could cherry pick, meaning that you could pick which pattern you feel appropriate or express suitable ontological commitments that you could tolerate for your local data. Yeah. And also obvious module division, yeah, because you have clear modularization. And how do we model that? Well, this is a typical collaborative modeling approach. So you start with a problem, and then you identify the notions. And the next step is that you do not try to collect them together to get a big ontology covering all the notions. Instead, you do an iteration where for each iteration you focus on one notion. So for example, you have cruise vessel, say urbanization, then first focus on cruise, or first focus on vessel, or first focus on urbanization, and so on. So one by one until you get nice modular ontology. And then you do that, you do axiomatization and so on. So with this approach, we were able to identify more than a dozen patterns that cover, I wouldn't claim all, but majority of notions in ocean science that are needed for data integration. There is a link there for giving an example. But let me give you an overall architecture. So you have architecture something like this, where so essentially each box here is a pattern, a small pattern. This is a small ontology, each of this. Yeah. And then when you have an ontology like this, you do not say, for example, there is a relation between where is cruise? So where is cruise? Yeah, and there is a relation with vessel through it is undertaken by a vessel. So you don't want to include axioms constraining the meaning of vessel inside the cruise pattern. Yeah. So you localize the axioms. Of course, it's hard to judge or you distinguish. Yeah. This is where the domain experts come into play. Yeah. They would say, well, cruise is just about this and this and this, and we ontology engineers would help, organizing the thoughts into axioms. Yeah. So the architecture would look like this. So this is the global schema. There's the local data sources, and the global schema would consist of patterns. Yeah. And here's an example of patterns. Yeah, very small. It's about person. Person is really just that. Person has personal information item, and personal information item could be name, could be nationality, and so on, and it's limited. Yeah? And this is after being axiomatized in formal languages, yeah, in OWL. So that's the main idea, right? So you have patterns. Of course, the other question is, whether it will be really suitable. So we did evaluation on that, and apparently patterns only are not enough. We need more. So what we need was, so it is, by the way, this is cruise patterns. Cruise consists of patterns from multiple patterns. So it uses patterns, these patterns, and so on. So kind of imports the definition of them, of the patterns. So for example, trajectory, this part is one pattern by itself. Yeah. Yeah. Let me go on. Yeah. Now the problem is that there is, so in terms of application, the study was done throughout the project, along the project, and then we get feedbacks. Apparently we need something more. We need another intermediate schema there. I'm not going to talk about the details of that approach, but rather just say that the idea is that you have simple set of modules, and then here you have simple, very basic schema without, it doesn't even have constraining axioms here. It's just stating the relations, the edges, and then mapping between these two. Yeah? And this could be used either with a data warehousing approach or virtual integration approach. Right, I think I should just conclude here. Just to give you the conclusion here. So that's what we did. We developed these patterns, and then we introduced this intermediate schema and also formalization of that intermediate schema. And we tried this with the data integration project, and the evaluation indicated that the data integration partners, the providers, are happy and satisfied with the results. And of course, it's not complete by any means. There are still future work to be done, both in theoretical aspects and practical aspects. I think I should conclude here. And maybe I welcome any questions. Any questions? Even the basics one is fine. Was it because of I use English? No? I'll be happy to finish the talk without any questions. Yeah. Well,
Thank you for this very interesting presentation. So one of my questions about maybe this is kind of simple questions. How would you come up with this ontology pattern? Maybe you could elaborate a little bit in a technical viewpoint. How would one come up with this ontology pattern? Thank you.
Thank you for the question. So concretely, there are different ways. Yeah. The source of, so remember, a pattern corresponds to one notion in the domain. So how do you first, of course here that means you need to somehow identify the notions in the domain. If you are an ontology engineer, you cannot do it by yourself. You need domain experts. Yeah? The knowledge of domain experts is the one that guides you to get to these important notions. The process could be done, for example, by maybe one way, maybe just brainstorming with the domain experts and list all the things they know about the domain. Yeah. Say if I want to find out about data about this thing, I need this and this and this and this, and then from there you get the notions. Or another source would be from corpora, text corpora. So for example, from publications. Yeah, you use publications, and there are approaches where they extract text from the text corpora and get important concepts there, and there will be candidates for the notions. But again, here you need confirmation from domain experts. Yeah, I tend to see that it is very, very unlikely that you will be able to do it fully automated. Yeah, but that's a process. And then if you get these notions, then you start modeling. Yeah, you start modeling. What you do is you ask the domain experts. If you have, say, cruise, yeah, or a person, for example, as a notion. So what does a person, or what, given a person, what must a person or the concept person have? Maybe it must have a name, or maybe it must have, well, depending on the data as well, right? And then from there you get axioms, and you as an ontology engineer would then translate this. You don't talk with the domain experts using OWL or using logical languages, just use natural language statements, and from there you translate this, you model this as the logical formulas. Any other questions? Liza, you want to ask? Oh, Mbak Mita?
Yeah, I would like to ask a question, but not really related to the presentation material. But as a Fulbright alumnus, how would you encourage attendees here, our audience here, and encourage them to study in the US for specific your field of study?
Okay. I'm going to speak about this for studying for PhD. I don't know about masters. One thing I would say, so one thing that I really like about studying computer science in the US is that you can do internships in IBM. You can do internships in Google. That should be enough motivation for that. Yeah. That's my short answer. You want a long answer? Other than that, the experts are there. I think, well, for me, I was fortunate because my advisor was really helpful, not just on the academic level, but also on the personal level. A lot of things not really related to the study, but if you don't have that, then study would be very, very difficult. Yeah, he was very helpful. For me, as somebody who wants to be a researcher, one thing in academia, one thing is also the network. Yeah, not every advisor would give you that, but what my advisor did. So even from the beginning, I remember I arrived there, and I think the first 2 weeks, I think in the second meeting, he said to me, we are writing a paper to submit to www, which is the highest tier of international conference in web science. And he said, I would like you to join. So that's what he did. It's really helpful. So I got my first publication before I finished my first year. Yeah. Another thing is that I don't know about others, but my experience that as senior researchers, he's often asked to be a program committee member, reviewer, right, or even senior PC member, things like that. So in a conference, and what he did was, if he is a PC member, he would ask me to review paper for him. It's a work for me, but it's helpful because throughout my stay there, I reviewed tons of papers. Not just 1, 2, but tons of papers. Yeah. In top tier conferences, so I know the standards. So I became aware about the standards of how you get into the conference. Yeah. Not just conference, but also journal. And later on, when I already on my third year or second or third year, I believe, when he was asked as a senior PC member, which means as senior PC member, he would not review the paper directly, but rather he would coordinate a number of PC members under him, right? So he would nominate my name as part of PC member. So that's why I got my name on the PC member in many conferences now because of that. And later on, and this helped me because then people know about me. Yeah, people know about me. People know about my work. And after my 4th year there, people would ask me to be a PC member directly without through my advisor. That's one of the things. But that's probably not specific for computer science, but that's what I experienced. Yeah, that's probably the long answer. And other than that, well, the US is beautiful, maybe no less beautiful than Indonesia. Any other questions? If you are interested in working on topics related to ontologies, linked data, semantic web, data integration, feel free to talk to me. We'll be happy to continue my work as well as when we're talking about other issues. One thing, if just a pointer, one thing interesting in Indonesia is one thing I noticed is the open data movement. Open data movement is where you have government data published as an open data, but that's not yet at linked data level. You cannot do integration with, or it's very hard to do integration with linked data, with open data from Indonesian government now. That's an open problem, by the way. If there is no question, maybe I should just end the session today. Thank you. Oh, you go.
Okay, this question is personal. Yeah. Before you departed and get the Fulbright scholarship, you are very musical. You saw guitar, you play it. We ask you to sing, you sing. But when you came back from US, you quit. You say, "What have they done to you, or what did you do?" Okay.
Let me just say one thing. I learned something that changes my perspective. That should be. I'm not going to tell you what's my new perspective or what. It's just a change of things. Thank you. Okay, I guess.
Probably if I want to do or start research in music, for example, there are tons of information out there. What should I do? You said talk to some expert in the domain.
Yeah, maybe not just music, but many topics, right? Yeah.
Specifically in music.
I don't know the experts, so.
Yeah,
But yeah, so in terms of funding, Mita already explained in the beginning that Fulbright offers many programs. You want to do masters, you want to do PhD. Mamita is here to answer questions. But for me, the good thing about Fulbright was that to apply to a university in the US, one of the things that sometimes discourage people is you have to do this TOEFL test, this GRE test, or things like that. I was like, when I applied, I was wondering, do I have to pay the GRE test for myself? Apparently not. Fulbright paid for me, so that's one thing. But yeah, so in terms of funding, that's what you would do. Or in terms of the content of the research, well, one of the things you do is you start with the publication of the people. Yeah? Don't be stuck with the name of the university, especially if you're doing a PhD. Yeah. Before I left Fasilkom 7 years ago, somebody told me, where is Rice University? I don't know about that university. It's kind of a small university. It's not well known. It's not well known. It's definitely not the first tier. But I got an advisor that is a world-class advisor. He is one of the most prominent names. So look for the advisor, not for the name of the school is secondary. If you're doing a PhD, masters might be different. But yeah. I think that should be it, Mamita. Thank you.
Thank you so much, Mas Adila. Let's give another round of applause for Dr. Adila Krisnadhi. So that is all our Fulbright research presentation for today. And before leaving this room, we would appreciate if you could submit the feedback form that we distributed to you earlier, so that we know how you would rate this presentation. And if you have questions about the Fulbright program, you can talk to me directly after this formality ends. And then we also provide you with brochures that we bring from our office in Jakarta, which contains Fulbright scholarship information. If you are interested in getting one, please let us know, because the brochures are right there behind this room. Thank you so much. Selamat siang. Assalamualaikum warahmatullahi wabarakatuh.